Today we're going to be starting Unit 4, which is Global Systems and Energy. In this unit we talk about some of the stuff we talked about in physics, some of the stuff we talked about in biology, and some of the stuff we talked about in chemistry. All right, so this unit is a real hodgepodge, okay, of lots of things. Okay, we talk about energy a lot, okay, in terms of how it's distributed on Earth. But we don't talk about mechanical energy. In this unit, we're talking about thermal energy. Okay, because we're talking about the energy that can be used to keep the environment good for plants and animals and things like that. That's not mechanical, that's thermal. Okay? We talk about the nature of water in terms of its ability to help with that process. There is some thermal chemistry stuff that we do in this to do with the heating curve of water and the specific heat capacity, which is a physical property that we talked about back in Unit 1 of various materials. Okay? And then, of course, the living things part also plays a factor. Okay? So as I said, there's a little bit of everything in this unit, okay, to kind of close things off. All right, so it's going to seem like we're jumping all over the place in terms of topics. Because we are. It doesn't just seem that way. We are going to be jumping all over the place in terms of topics in this unit. Okay? It's just the nature of the last unit. All right, so what we're going to talk about today are the components of climate. That is the things that make up climate. Right? We're going to talk about the factors that affect those things that make up climate. Okay? What things make the climate in, let's say, Okotoks the way it is. All right? And we're going to look at inputs and outputs of various environments. Okay? And we're also going to talk a little bit about climate graphs or climatograms, because when we come back from Christmas, the first thing we're going to do is a little climate graph analysis activity for Canadian cities. All right? So, what would we consider to be part of climate? If I'm talking about the climate of an area, what four things would I talk about? Temperature. Temperature would be a big one for sure. Okay? I mean, it's the thing you check on your weather app before you walk out the door in the morning.
Humidity.
Humidity could be part of that, but it's actually related to a different part. But it's certainly something we'd be concerned about.
Precipitation.
Precipitation, okay? It's probably the other thing you check when you leave the house in the morning. Do I need a coat, an umbrella, okay, whatever. Wind, yeah, especially around here, okay? We got to know whether, we're going to blow away and land up in Oz, because sometimes that happens here, okay? When we get those 130 kilometer an hour Chinook winds, okay, coming in. All right, last thing. This is one people don't think about, but it changes for us a lot. And we're coming up on the least amount of it.
Pressure.
That does change for us a lot. That's a good answer. It wasn't what I was thinking though.
Daylight.
Daylight. Yeah. The amount, and not just the amount, but it's also the intensity of the light that you receive. Okay? These are the four components of climate. Okay? The amount/intensity of light an area receives directly relates to how much energy it will have. The only effective source of energy for Earth is that big bright orange thing in the sky. Okay? And how intense and direct, okay, and what the duration of that light is affects your climate. Okay? Does that sort of make sense? It's why cities at the equator are warmer than cities here. Okay? They always have the sun directly overhead. Right? And they get 12 hours of day and 12 hours of night pretty much all year long.
What is this unit called?
This unit is called Global Systems and Energy. Okay, temperature is obviously influenced a bit by light, okay, but it's a big part of climate. It determines what kind of things can live there, okay, the amount of precipitation, same thing, the availability of water is a big factor, right, and wind, okay, can also be a big component of climate simply because it can affect, how dry a place can be. Okay, if you ever look at trees down by Pincher Creek, okay, they'll grow bent into the wind or with the wind. Okay, so all of those things are the main factors that affect, the main components, the four components of climate. That went too far. Uh-oh, my slides are out of order. Oh, no. Where? There's a slide missing. That's not good. So, when we describe the climate of an area, okay, we are describing the prevailing weather conditions at a particular location. That is not the same as the averages. Okay, a lot of people say climate's the average weather at a location. I don't know what average weather means. Okay, but here's what it sounds like. If I'm saying that the climate of Okotoks is the average weather in Okotoks, I would say the climate in Okotoks is this. The average temperature in Okotoks is plus 5 degrees Celsius. You will get about 2 millimeters of rain per day. You will have winds coming from the southwest at about 40 kilometers per hour. And you will receive 12 hours of sun and 12 hours of darkness. Does that sound like the climate of Okotoks? No, those are the average numbers. That doesn't make any sense at all. That's not what Okotoks is like. Okotoks weather varies. Okay? We have seasons here because we're far from the equator. Okay? And that's related to the factors that affect light, temperature, precipitation, and wind. Okay? All right. What's going on in this picture? What kind of a cloud is that? Think back to grade 8 meteorology. Cumulonimbus cloud. This is a thunderhead. Okay, we get these in the summertime. June, July typically is when we see the most thunderstorms. They are produced by an interaction of the 4 components of climate. You don't get a thunderstorm every day. The conditions have to be just right. Okay? What are the conditions that normally build a thunderstorm? What's the temperature like on a day like that?
Warm.
Usually pretty warm. You need a lot of energy to build a thunderstorm. Okay? It's usually pretty warm. What else is there a lot of?
Humidity?
Actually, there's usually very little wind because wind disrupts the formation of the thunderhead. So we usually have to have a pretty calm day. There is a lot of humidity on a day where we would build a thunderhead. Okay? And does there have to be a fair amount of light? Yeah, we don't get these in December. Okay? We need those days where it's 16 hours of sunshine to build, have that energy present to build this kind of a storm. Okay? Because these storms, what they do, okay, is the hot air starts to rise. It takes with it a lot of the humidity. Okay? So the hot air is rising, it's pushing the warm, moist air upwards. Okay? And as that moisture gets higher up and the temperature begins to drop, okay, what happens to that moisture? It goes from being humidity to being,
Ice.
well, it could eventually be ice, okay, but at least the first time around it's just rain, yeah, liquid water. Right? It goes from being water vapor, humidity, okay, to being liquid water. As a thunderhead builds throughout the day, it doesn't start out this tall, okay, but what happens is that warm, moist air starts going up, okay, and as it goes up, the water inside of it condenses. When the water condenses, it tries to fall back down now as liquid. On a day when we get a thunderstorm, though, there is so much upward pressure from this heavy, hot, moist air, okay, that it will actually push that liquid water back up into the cloud. Okay? And the more times this happens, the more moisture condenses and the bigger the raindrops get. Okay? Like you've noticed probably with a thunderstorm that sometimes when you get just a little mild one, the raindrops are pretty small. Okay? When you get a really intense one, the raindrops are a lot bigger. Okay? Well, if they continue to go through this cycle and get up into the top part, especially if it starts to make like an anvil shape at the top, okay, where it gets really flat on the top, okay, you can get above the freezing point of water, or you get to an altitude where you're below the freezing point of water, I should say. What'll happen to the water then? It'll freeze, and it'll turn into, right. Anyone ever crack open a hailstone? Next time it hails, wait till the hail is done, then go outside, okay, and get a hailstone, especially if it's the big stuff. If you got the golf ball size one, those are really good for this, not in general, okay? And just take a hammer and just break it. And if you can get it to split, it'll look like an onion inside. Okay? Because the formation of a large hailstone involves that hailstone trying to fall down, but the upward pressure of the warm, moist air pushes it back up. all that moisture condenses on the outside of the hailstone, making it bigger. But you can actually see the layering effect of how that hailstone built over time. Okay, so the more times it goes through, the bigger the hail is going to get. All right, if you get the golf ball size one, it's gone through probably 4 or 5 times. Okay, if you start getting like the baseball size ones, you're probably looking 5 to 10 cycles. Okay, if you get the grapefruit size, those are real bad. Okay, believe me, they happen. Okay, back in I think it was 2004, they had those out in the Wainwright area. Grapefruit size hail. Okay, like a softball. Okay, people's roofs, windows, everything, like not just the shingles destroyed, like they went through the roof in some places. Every car dealer in the whole town's entire inventory, brand new cars, written off for scrap. Okay, they were just full of holes. Okay, they were only good for parts. Okay, so it's a big deal when you get those really big ones. Biggest one ever recorded, an ice cream pail. Okay, when it was melted, it had 4 liters of water in it. That's not one you want to get hit by. Okay, just saying, even a helmet is not going to save you with that. Okay, that's really, really big. Okay? It's of course an anomaly, but it's really, really big. Okay, even golf ball size hail. Like we live in a hail belt. Most people will never see a golf ball size hailstone in their whole life. Okay, we see them once a year. Okay? That's why our insurance costs are higher here. Right? But it just happens that the conditions are right here. Our climate is right to build those kinds of storms during certain parts of the year because the interaction of those components is just right. Okay? Or just wrong, whichever way you want to look at it. I'll pick glass half full today. All right, the factors that affect climate are as follows. So these are the things that make the climate of an area the way it is. The number one factor affecting the climate of an area is your latitude. That is, how far from the equator you are. Okay? The reason latitude affects your climate is because it affects the duration and intensity of the sunlight you receive. We are quite far from the equator. We are over 50 degrees, I think we're actually like 51 degrees north of the equator. Okay? That's pretty far. We're definitely more than halfway, okay, north from the equator. So what happens for us, okay, is at least throughout the year, the amount of area the sun hits changes for us. Okay, so if this isn't quite on the equinox, okay, but it's tilted just a little bit. This would probably be maybe end of October, okay, condition. So we're tilted slightly away, okay, or the North Pole is tilted slightly away from the sun. If you're at the equator, you get a certain amount of solar energy, and it hits an area as big as that blue line I just drew. Okay, so the sun is basically always directly overhead, regardless of what the tilt of the earth does. You guys are aware, right? Tilt of the earth causes the seasons, right? Okay. Sometimes I have people tell me it's because the earth gets further away from the sun, which is true. The earth does get further from the sun, but we're actually further away in the summer. Strange but true. Okay, so at any time of the year, at the equator, the tilt of the earth doesn't really affect you, okay? The equator kind of swings through an arc, okay, that looks kind of like this. It's always directly under the sun, right? They don't get a lot of change in their intensity or length of day, not like us, okay? The further away from the equator you go, you're getting the same amount of sun, but now, because the earth is round, we've covered that before, okay, this amount of sunlight now is covering a larger area, which means it's not as concentrated. Okay? Everyone kind of with me there? Look what it's like for us. Okay? That same amount of sunlight is covering easily twice as much area. We're getting half the intensity of the sunshine that the equator is getting on this particular day of the year, right? It's exacerbated for us, Okay? Because the Earth tilts back and forth 23.5 degrees, okay, actually 46 degrees when you consider both ways, okay, it can change the intensity of our sunshine quite a bit. The other thing it can affect is how long the day is. You've probably noticed you're at this time of the year, you're coming to school in the dark and you're going home in the dark, okay, because the days are really short. Okay, what's going to be the shortest day of the year?
December 21st.
All the days are 24 hours is a trick question. But the shortest amount of daylight, okay, is going to be December, I'm sorry, I couldn't resist, okay, is December 21st. That is our shortest or our least number of hours of daylight. And that's because on December 21st, if the sun is out here on the right-hand side here, okay, our axis is tilted, that color's not going to work there. Our axis is tilted like this. Okay, so what happens for us is we end up not getting in the sun nearly as much. This dotted line represents the part of the Earth that can receive sunshine. So when the Earth spins on its axis, the solid line like this, we don't spend very much time in the sun. We spend more time on this side of the terminator. That's what that line is called. Okay? It is the line that divides night from day. Okay? It has a great name. If you were going to get a nickname, the Terminator would be a great nickname. Okay, so we spend more time here. We rotate around and around, and at the North Pole, you would not see the sun. Okay, right now they are in what they call the dark times. They run from about the end of November to about the middle of January. Okay, they basically get no daylight. Okay, the North Pole is completely facing away from the sun, and as the Earth rotates around, it just never gets into the sun. In summer, what happens?
It does 40 days where it doesn't
Right.
set.
Yeah, they get the same amount. They get the light times, and no one can sleep because it's always light outside, and you can actually watch the sun move in a circle. Okay, because it can't set. Okay, because in the summertime, the Earth is tilted like this. So now the North Pole is always in the sun because the terminator is here now. Okay, so when the Earth spins around and around like this, if you're standing at the North Pole, you watch the sun go around and around in a circle and not set. Okay, it's really strange apparently. I've never seen it myself, but okay, apparently it's pretty strange to see. So here on June 21st, what do we call June 21st?
Summer solstice.
The summer solstice. This is the
Winter solstice.
Okay, March 21st, September 21st are the equinoxes. Okay, that's when the Earth's axis is perfectly straight up and down. Everybody on Earth gets 12 and 12 that day, or those days, right? So that's why you see kind of this, right? The axis is straight up and down on those days. All right, everybody okay with that idea? All right, so that causes a change in not just how many hours of sun you get, but also the intensity of the sun you get. Right? That's why it's cold here through the winter. We not only get very little hours of sun, but the quality of the sun we get is decreased. Okay? Like this, I said, was kind of like maybe end of October. Well, that's still almost 2 months, or at least a month and a half, from the furthest we would be pointed away. The further away we point, the bigger this yellow circle gets. Okay? And that yellow circle, no matter how big it gets, still represents the same number of joules of solar energy. Okay? So the bigger the area it has to spread over, the less intense the sunshine is. Okay? Not to mention that it also affects how many hours a day you get it. All right? Has anyone ever noticed, like right now, the sun kind of rises over there and sets over there? But in the summertime, it rises over here and sets over there. Okay? Because we're tilted differently. Okay? So we see it differently and we stay. That's why Stonehenge and those kind of places work the way they do, right? The sun comes up between two stones on one day of the year and between two different stones on a different day of the year based on the tilt of the Earth. Okay? It's something you observe and you'll see it. Okay, everyone all right with that? Okay, here's how I'm going to ask a question about factors affecting climate. Okay? I'm going to pick a city in Canada. And I'll even put a map on there and I'll point an arrow in case you don't know where the city is. But I mean, you should kind of know where most of it, I'm not going to pick like something obscure. Okay? And I'm going to say, based on what you know about factors affecting climate, tell me what the components of climate or the climate of this area would be like. Okay, so as we go through these factors, you got to think about, okay, which of these would affect certain places. That's the purpose of the activity we're doing when we come back after Christmas. Okay, could you use latitude for any city? Yes, latitude always affects your climate. It doesn't matter where you are on Earth. Latitude is a factor that affects everybody. Okay? I don't see a lot of people writing that down, but that's like a big gimme. Okay? You can always write latitude if a question is asking about what factors might affect this place. Latitude will always affect it. Okay? Because every place on Earth has a latitude. Okay? Be it large or small. Okay? The second factor is also one that could essentially be used for pretty much anywhere, and that's altitude. The higher up you go, the colder it gets. About 6 degrees for every vertical 1,000 kilometers you go. Okay, to give you an example, Denver, Colorado is at an altitude of about 1,580 meters. Its latitude isn't that much different than places in California. But Denver is considerably colder. Okay, they get a lot of snow in Colorado. Okay, but it's a difference in altitude. They're the same distance from the equator, but because it's so much higher, it's also typically colder. It's why snow remains on the tops of the mountains well into June, most years, okay, versus down here where it's all gone. Okay? The top of the mountains you can see here, okay, some of those are 3,000 meters high. Okay? Here in Okotoks, at this school, we are 1,096 meters above sea level. Okay? So they should, on the tops of the mountains, typically be anywhere between 10 and 15 degrees colder than here, just based on their altitude. Okay? So in this picture here, okay, kind of a day where I saw this happen firsthand. I took this picture before you were born, which is a little embarrassing. Okay? But I was doing a backpacking trip, and this is Mount Robson here. Okay? It's the highest point in the Canadian Rockies. Our campground that we started from was down over here somewhere. Okay? At an altitude of about 1,700 meters. Okay? Mount Robson is, I want to say, closer to like 6,000 meters. It's quite high. Okay? As we came up, when we left our campsite, it was about 13 degrees and it was raining. Okay? When we got to this valley here, okay, we were at close to 2,200 meters, almost a vertical kilometer higher than where we had left. Okay? Temperature here was just above freezing. It was raining at our campsite, and the rain was just starting to turn to snow here. Okay? And keep in mind, this is on July the 8th. Okay? Now I know it's 2003. There's been climate change and global warming since then, but trust me, it was getting colder. Okay? Now, if you look up onto the face of Mount Robson, you can see that there's glaciers here, okay, things like that. But on the top of Mount Robson that day, okay, there were people who were making summit pushes that day, and they were experiencing minus 25 on the top of that mountain in July. Okay? That's just a matter of altitude. Like from where I took this picture to the top of Mount Robson is not a great distance away. There's not a huge change in latitude. It's probably pretty much the same. Okay? The only thing that changed was they were several thousand meters higher. Okay? And so it was much, much colder. Okay? You want to follow the effect of altitude? Altitude makes it colder the higher you go. All right? So a place like Calgary versus a place like Victoria, okay? Well, let's say Vancouver. Their latitudes aren't that different, okay? But their altitudes certainly are. We're a full vertical kilometer higher than Vancouver is. Okay? So on average, we should be about 6 degrees cooler. All right, a couple of other factors. Distribution of land and sea. Okay? Does being near the ocean affect your climate?
Yes.
Yes. Okay? In a few ways. It's a big source of moisture. Okay, so it's possible, but not always, okay, a situation where you could get greater precipitation. But it can also affect your temperature. If we go back to the Vancouver and Calgary comparison here, sure, Vancouver's got a lower altitude, it's at sea level, okay, and it's right on the ocean. Does it ever get super windy in Vancouver? It never gets super wintry in Vancouver. Okay, coastal BC is exceptionally mild, right? If it snows there, it shuts the whole city down. Okay? They don't have snow removal equipment there. You need it. Okay, so their climate is considerably more mild in terms of their temperature rarely drops below freezing, even though they're the same distance from the equator that we are. Okay, 6 degrees worth of altitude difference is not making that up. Okay, it never gets to be minus 30 in Vancouver. We get that all the time. Okay, so there's another factor at play here, and that factor is the deep blue sea. Okay, water can hold vast amounts of energy, and it doesn't change its temperature very easily. Okay, to change its temperature, water has to either lose an incredibly large amount of energy or gain an incredibly large amount of energy. Okay? This is going to sound not incredibly large, but 4.2 joules for every gram of water to change it by 1 degree Celsius. 1 gram of water is 1 milliliter. Okay? That's an exceptionally small amount of water. But it takes 4.2 joules worth of energy to change that by 1 degree Celsius. Now you imagine how many grams of water are in the ocean. Okay, it's a massive heat sink. It can just hold all of that energy. So let's say a cold front moves into Vancouver. The air gets colder. Okay, the temperature of the air might be, -3, -4. But the temperature of the ocean the air is sitting over is +4, +5. Which way is the energy going? Which one's hotter? The water's hotter, right?
Yeah.
Second law of thermodynamics says the energy's got to go from the water to the air. So the ocean regulates the air temperature because of the second law of thermodynamics. And that air doesn't have that same heat capacity, okay, that ability to gain energy and not change temperature. Okay? Where water was 4.2, air is like 0.8. Okay? So the energy that comes out of the water barely changes the temperature of the water, but can change the temperature of the air by almost 5 times as much. Okay? So being near the ocean can affect your air temperature by essentially regulating it. Okay? Everyone kind of follow there? Now, it does depend on what kind of water you have. Okay? In the Pacific, on the west coast, that ocean water is warm. If you've ever been in the Pacific Ocean off BC, it doesn't feel that way. Okay? But that ocean water is warm. It doesn't freeze there. Okay? If you go to Newfoundland, the ocean freezes near the coast. Okay? It's colder. Reason for that? The second thing on here. Where does the water that's in the ocean where you are come from? Because believe it or not, the ocean is moving all the time. Okay? There are all these big ocean currents that are constantly moving water around. So if you look here off the coast of North America, you've got the Alaskan current, okay, who is always bringing warm water from the North Pacific current, okay, and bringing it right up the coast here where Vancouver and BC, and all that stuff is. Okay. Meanwhile, the California current is a little bit cooler. Okay, cooler. It's not cold. Okay, and then you've got all these currents here. You got the North Atlantic current, okay, which is warm. The Gulf Stream, which is warm. Okay, and then the reason Newfoundland and Labrador are cold is because they have the North Atlantic or the Labrador current here. Okay? The Labrador current comes out of the Arctic Ocean, which is usually covered in ice. Okay? So it's constantly bringing colder water, so its ability to regulate temperature is limited. Okay? So it's usually colder and icier on the east coast than it is on the west coast. because the ocean temperature is several degrees cooler. Okay, everybody all right with that? Okay, now you can see down here, okay, in the Atlantic, you can see all these currents here, and the Gulf Stream goes right up the eastern seaboard of the United States. What else follows this? Hurricanes. The Gulf Stream is the hurricane builder. Okay? It's a warm ocean current, and when you've got warm ocean water, you can build massive storms. And that's why they always follow the same track. I don't know if you've ever watched the hurricane track, but hurricane tracks are like basically always the same. They start here. They go around and hit all the little islands in the Central Americas here, and in the Caribbean, and then they go up past Florida, and they get everybody. And sometimes they do get as far as Newfoundland. Okay, they'll sometimes get the tail end of those hurricanes when they're back down to a tropical storm. Okay, they'll get the tail end of those sometimes, but they always follow that warm water because they need warm water to build. Okay, if they get off that track and move inland, they die. Yeah, and that's usually what happens to them. They eventually slow down, they get pulled into the land, and they die. Okay, but for the most part, they'll follow that Gulf Stream, and that's what continues to build them up. Okay, so we've got proximity to the ocean. Ocean can regulate your temperature, okay, because it's a big heat sink. Ocean currents determine the temperature of the water that the area receives. Okay, so that can also help to influence how much moisture an area gets and how warm that area is. Okay, if you look over here, okay, to the Canary Current that goes off the northern Africa, okay, this part of northern Africa is incredibly dry, and that's because this ocean current is actually colder, which doesn't create as much humidity or as much rainfall. Okay, so that's why like Tunisia and Morocco and places like that are very dry. Okay, questions so far there? Okay, this is one that affects us greatly. Okay, if I was asking you what are some factors that affect the climate of Okotoks, I'd say latitude, altitude, and mountain barriers. Okay, our proximity to the Rocky Mountains has a huge influence on our climate. One of those huge influences is something we talk about and get here all the time. But if you talk about it with someone who's not from here, they have no idea what you're talking about. What are they, Tristan? Chinooks. Okay? You tell someone who's not from around here, oh yeah, we had a Chinook today. They'll go, is that a native word? Like, what does that mean? They don't know it. Okay? Because it's a very localized phenomenon. Okay? Only a few places on Earth actually get these kinds of winds. Okay? Leonardo DiCaprio certainly doesn't know what they are. Okay? I don't know if you guys remember this, you're probably too young, but okay, when he was filming The Revenant here, okay, he went on Twitter because we got a Chinook, and he raked us over the coals about being this place that starts climate change because he witnessed climate change firsthand. The temperature went from -20 to +10 in a matter of hours. And he got slain in the comments because everybody from here is like, it's called the Chinook doofus. Climate change is the gradual, over time changing of weather conditions at a particular location. It doesn't happen in 6 hours, you idiot. Okay? But of course, all of his followers are like, oh yeah, you're totally right. And then all the people here are like, God, you're so dumb. Okay? So anyway, it was a big thing for quite a while. But it's because people don't know what Chinooks are. If they experience them, they are we're used to it. But if you were here and the temperature swung by 30 degrees Celsius in a matter of hours, that would be a little shocking. Okay? But it happens here. But it only happens because we have the mountains there to get it started. You ever notice there's always a certain cloud formation before a Chinook? Okay? Next time you get a Chinook, you'll see it. It's called the Chinook arch. Okay? There's a sharp border of the clouds, and it looks kind of like an arch because it kind of follows the shape of the mountains. Okay? That's produced by the massive pressure change that accompanies a Chinook. Okay? So we get Chinooks, and we're a fairly dry place because of the presence of the Rockies. So what happens is our prevailing winds come from the west, which means they start out in the Pacific Ocean. And the air that they move is actually quite heavy and moisture laden. Okay, so there's a lot of precipitation potential in it. Problem is as that moisture laden air moves towards the mountains, it has to go up and over. Well, as it goes up, what happens to temperature? It goes down. What happens to water if it drops below a certain temperature?
Freezes.
Well, or it'll precipitate, it'll condense, maybe it'll freeze as well, it could be snow, it could be rain. The point is, all that moisture falls on BC, on what we call the windward side of the mountains. Okay, the side the wind hits first, the windward side. Right? That's why if you go to BC, you see thicker, temperate forests in BC. You even see like those giant redwoods. If you've ever seen Return of the Jedi, okay, when they were filming Endor, all those big giant trees, that was actually filmed in parts of BC. Okay? We get this temperate rainforest in BC because all the moisture falls on their side. By the time that air finally gets up and over the mountains, it's cold and it's lost pretty much all the moisture it contains. Okay? Now, thankfully, gravity will say, hey, come back here, okay? And it'll start bringing that cold, dry air down the mountain. Well, as it moves down the mountain, it picks up,
Moisture.
actually no moisture, but speed. Okay? Gravity is pulling this air mass, dense, cold air, down the mountain. And it's picking up speed. And as it picks up speed, it rubs against the mountains. That creates friction. And it piles on top of itself, raising the atmospheric pressure. Okay? So you get this massive pressure change where there's clear sky over the mountains, and then there's this much lower pressure area where we see the clouds. And there's a distinct cutoff between the two. Okay? If you see that Chinook arch, you know the wind is coming. Okay? Once those clouds move over you, then the high pressure stuff that's in the clear area is going to be on top of you. Right? So what we end up getting is warm, dry air coming flying off of the mountains, okay, as a Chinook. But you have to have those conditions. The wind has to go the right way. The mountains have to be tall enough to eliminate the moisture on one side, okay, in order to build a Chinook condition. Okay? But mountain barriers, which cause what we call rain shadows, okay, happen all over the world. Okay? So right here, okay, you can kind of see the effect of that. On this side, everything's green. You got your mountain range right here. Okay, you can see all the snow on the tops of the mountains, and then on this side it's desert. Okay? Many of the deserts in the world, the Sahara being an exception, are rain shadow deserts. Okay? The Mojave Desert in the United States is a rain shadow of the Rockies. The prairies where we live are a rain shadow of the Rockies. This is the Gobi Desert. These are the Himalayas. You've got tropical rainforest on one side of the Himalayas, and you have a high altitude desert on the other side because no moisture gets over top of those things. They're 3 times taller than the Rockies. Okay? Moisture's got no chance of getting over top of those. All right? So you get a rain shadow if you've got high mountains, and on one side there's moist air, and it has to get up and over. Okay? So that one is probably, after latitude/altitude, the biggest factor affecting climate here. Okay, everybody understand how the mountain barriers work? All right, patterns of prevailing winds. Where do your winds typically come from? Okay, well around here our winds typically come out of the west-southwest, which means they typically bring the same kind of air, which makes, conditions relatively stable. Okay? We're not suddenly getting, massive changes, although we do have that expression in Alberta, if you don't like the weather, wait 5 minutes, okay? And that's partly related to where we are, okay? And it's also related to the location of high and low pressure. Okay? There are some places in the world that are always high pressure and some places in the world that are always low pressure, okay? And if you've got a pressure difference, everything wants to move from high to low. That's the natural movement of things. So if you've got a high pressure area in one place and you've got a low pressure, that's so weird. Oh no. Okay. Just stay there. Okay, so right over here, I get to play weatherman now. Okay. Sorry, I wrote high. I meant high is supposed to go over here. Okay, right in here, you're starting to annoy me. Okay, right in there, over like the Northwest Territories and none of it, okay, is what we call the Siberian high. It's almost always high pressure in that area, which means the skies are generally clear and the temperature is generally cold. Okay, over here, okay, right where the Yukon, BC, and Alaska kind of meet, is what's called the mother low. Right? It is always a low pressure area there. That's why this whole area is some of the highest precipitation in North America. Right? The low pressure usually breeds lots of precipitation. Well, here's the weird thing about high and low pressure areas. Air rotates around them. Okay? Rotation around a low is clockwise. Rotation around a high is counterclockwise. You know when we get those wicked storms? Okay, like in the summertime, we get like a chain of thunderstorms. In the wintertime, we just get that one big storm like we had a few weeks ago that just dumps snow for days. Okay, they are usually the result of the interaction between these two pressure areas, because anything that gets thrown off of the high pressure area is going to be cold and dry, and it's going to want to go right here. Anything thrown off the low pressure area is going to be warm and moist, and it's going to want to go to the same place. And look where they meet. Right down Highway 2. Okay? It's not by accident, okay, that we get the worst storms right through here. We're the tornado alley of Canada. Why? Because all the bad stuff wants to meet right here, where people are cool. Us. Okay? It wants to party here. Okay? So they meet in the middle there, and when you get cold, moist air, or cold, dry air, meaning warm, moist air, things are going to happen. Okay? Which direction is it going to feel like the wind is coming from when this happens? Yeah, not just the north, but the northeast. Anything good weather-wise ever come from that direction?
No.
Not ever. Okay, we got a northeast wind, we're in trouble. Okay, nothing good weather-wise ever comes from the northeast. But most of the time, the wind comes from the southwest, and you know it can be relatively predictable. All right, so those things can also affect your climate because they bring changes in the weather. All right, I think that was it for today, right? We'll talk about climate graphs tomorrow.
Mr. Coder,
Yes.
so for the